Basically, today we are going to talk about a very two important reaction that is important for your NEET examination. Okay, and see, first of all, conceptually, if I think that these two reaction basically connects the important part of your organic chemistry aldehyde ketone chapter. Okay, so the reactions are aldol condensation and the Cannizzaro reaction. The problem usually which you students face that whenever we give you a reagent, okay, reagent and a reactant, let's say in these two cases, let's say we are giving you sodium hydroxide solution. Okay, so you basically confuse out that in which case it will give you aldol condensation or which case it will give you Cannizzaro reaction, right? So I am going to solve this problem today, and you just focus on the video till the end and let's see what actually is there. So what we will do, we will focus on the problem and we will also cover up the reaction mechanism of these two reactions, so that in future whenever you get a unknown problem, you will be able to solve that issues. Okay, so let's start. So here if you see very clearly that in these two particular compound, in one compound there are 3 alpha hydrogen atoms. Okay, now alpha hydrogen with respect to this aldehyde group, and this alpha hydrogen is basically a acidic group. Okay, so this is basically acidic hydrogen. Now what do you mean by this acidic hydrogen? That due to the electron withdrawing tendency of this aldehyde group, this hydrogen becomes electron deficient, so it is acidic. Very simple concept. And but here if you see in this corresponding molecule, this is benzaldehyde, or here in this carbon do not contain any alpha hydrogen, right? So basically this OH minus, which is a very good nucleophile as well as a base, it will work in two different reagents differently, right? So देखते, in this particular case, since there is an acidic hydrogen present, the first job of a base, that is sodium hydroxide, will be to capture this acidic hydrogen. But in this particular reagent where there is no alpha hydrogen present, so what it will do, instead of capturing the acidic proton, it will try to attack the nucleophilic carboxyl carbon center. So this will leads to the two different kind of product. Okay, now let's see what kind of product is there. The first case, this comes under the part aldol condensation, and the second case comes under the part of the Cannizzaro reaction. Now let's see both of the reactions separately, how the mechanism happens. Next, let's start with this particular molecule. Let's say CH3 CHO. Okay, now what it will do here, now this OH minus which was there in the medium, this OH minus will capture this hydrogen, right, and it will make an anion. So what does it forms? Let's see, what does it form? CH2 C double bonded OH minus. Now this particular carbon ion is resonance stabilized, and this particular molecule is called an enolate ion. This particular molecule is called enolate ion. Enolate ion. Okay, now this enolate ion is a very reactive species. So what it will do? It will react with another species of acetaldehyde to make a couple reaction. Let's see. So I will take another CH3C bonded O. So as a result, what will happen? This will go back and this will attack like this. Perfect. Okay. So next step, what product is formed? I am writing the final product here. CH3C double bonded O CH COH H CH2 CHO, and this particular molecule undergoes a dehydration. This particular molecule undergoes a dehydration and it forms CH3C double bond CHCHO. Okay, like this. So this particular molecule is called alpha beta unsaturated carbonyl compound, which is basically the final product of the aldol condensation, right? Now this is the overall pathway that how a aldol condensation reaction proceeds. Now what happens in case of the Cannizzaro reaction? Let's see. So in this particular case, which we have taken the molecule benzaldehyde, so here this OH minus, what it will do, now it do not have any kind of alpha hydrogen here, so that it will go and attack or capture it and make the aldol condensation. But instead of that, what it does, it actually attacks this carbonyl carbon center, and next step what happens? Like this. Now see, this tetrahedral reaction intermediate is very reactive species. What it will do? Now this one will react with another species of benzaldehyde, but in a little bit different way. Let's first draw that another species. Like this. Okay. Now what will happen here? Now if you see here very clearly, this will go back. Now it has two options, either it can remove the hydrogen or it can remove this OH. Now if it removes the OH, we will getting back the benzaldehyde. So there is no point of doing that. But what it will do, it will, rather than removing the OH, it will transfer the hydride to the another molecule of the benzaldehyde. Now see here, one thing, this step is called hydride transfer. This step is called hydride transfer, and when we do this hydride transfer in reduction reactions, so what we can say that? We can say that one molecule of benzaldehyde is getting reduced. Now what happens to this molecule which actually transfers the hydrides? Okay, now this particular molecule, what it does, it actually converts to the corresponding acid. This actually corresponding to acid, but since it's an alkaline medium, okay, so it will be staying as the sodium salt, okay, which further actually upon acidification, it actually converts into the corresponding benzoic acid. So basically, and what about this one? This molecule transfers to the formation of CH2OH, that is benzyl alcohol. So here specifically one thing is for sure, that the two molecules of benzaldehyde are getting involved in the particular reaction, whereas one molecule of benzaldehyde is getting reduced to benzyl alcohol and another molecules of benzaldehyde is getting oxidized to benzoic acid. So it is basically nothing but a disproportionation reaction in organic chemistry, and which is known as our one of the favorite Cannizzaro reaction. Right. So finally, at the end of the day, what will be the message? The message is basically that if I have an acidic alpha hydrogen with respect to the carbonyl group, this molecule will give me the aldol condensation product, right? So you have to identify which is there or not. If one alpha hydrogen is there, still it will give you your aldol condensation. But if there is not a single alpha hydrogen present, straight away it will give you the Cannizzaro reaction. But what happens if I have two molecules with no alpha hydrogen, or two molecules with, let's write this one, this case, third case. So what will happen if I have this particular case? Let's say my molecule 1 and let's say this is my molecule 2. Okay, and now in this case you have alpha hydrogen, and here also you have alpha hydrogen, the two different molecules having alpha hydrogen atoms. Here there is no alpha hydrogen, but this molecule have alpha hydrogen. Or reversely, this molecule has alpha hydrogen, this molecule has no alpha hydrogen. Or there is no alpha hydrogen here, no alpha hydrogen here. So there are 4 different cases where we will find there is known as the cross Aldol condensation, and it's also known as the cross Cannizzaro condensation. It happens where we get the mixture of different kind of products, mixture Aldol products, mixture Cannizzaro product, okay, and that we will talk about in the next video, okay. So till then, if you have any question, just write it down in the comment section, share with your friends, and if you have any doubts, or if you want that if you want us to make more and more conceptual videos on the future, you just write your doubts and the topics which you want to make us to make the videos. So write in the comment section. So from my end, from the PrepMed team, bye everyone, take care.